So our last type of sedimentary rock are the chemical sedimentary rocks. So these are forming from a chemical solution, right? So we're having a chemical reaction here. And most of these are going to form precipitated from water. So as water evaporates, right, or as water moves around, we're going to get material that's going to form. We have several different types. We have some that form from evaporation. We've got travertine, which is kind of a cross. Here we'll see between biochemical and chemical, dolostone, and replacement chert. I love this picture because this is a huge salt mine. Salt forms from evaporation, right, as water evaporates away. So we can get lots and lots of salt left behind, which is very common in Louisiana. So definitely a good thing to know there. So our first type, like I said, is evaporites, and that forms just as the word suggests, from evaporation. Water is never just water. Water always has dissolved stuff in it, and most of the time some of that stuff is salt. Even fresh water has salt in it, just a little bit. So what we tend to see is water is going to collect in a nice big basin here. Over time, that basin is going to dry up, right? Maybe evaporate, and you're going to get lots of salts left behind. Or you can also get the mineral gypsum, right? Which, remember, makes up the plaster, right, in the walls of your house. You can also get travertine. Travertine is actually a type of limestone, so biochemical, usually forms in caves or in a system basically where we've got water that's really heavy, and it's got all of the carbonates in there, that carbonates being CaCO3. It's got water with a lot of carbonates in there. And what will happen is carbon dioxide will leach out into the system, so you're going to kind of get this carbon brine, and that's going to form travertine. So we tend to find, like I said, travertine in a lot of caves, right? You've got a lot of restricted water in there as it starts to evaporate, right, leaving behind that dense brine. Or in hot springs, like this is Mammoth Hot Springs in Yellowstone National Park. The heat there is causing a lot of that water to evaporate away, causing the travertine to get deposited. We can also get dolostone. Dolostone is limestone that's been altered by water that's containing a lot of magnesium. So we start out with limestone. The groundwater works across that limestone, and if that groundwater has a lot of limestone in it, it's going to leach into it, right? And you can see here the chemical structure it's going to attach. Dolostone really looks like limestone, so sometimes it's kind of hard to tell the difference. It's not going to fizz very well with hydrochloric acid, and it kind of feels like sugar, so it feels a little bit different. And then lastly, we can get replacement chert. So the important thing here is it's non-biogenic, so it's not formed from the shells of organisms. This is just microcrystalline quartz, and it's going to replace other things that are there. For example, right, petrified wood. Petrified wood, as you can see here, this was once a tree. It is no longer a tree. What happened was there was atom by atom replacement. You have an atom of wood, an atom of quartz comes in, or a molecule of quartz comes in and replaces it. So this is a molecule by molecule, atom by atom replacement, very, very slowly. You can get flint, right? This is flint. This is just, this is quartz that has a lot of organic material in it. You can get jasper, which is yellow or red. Quartz has a lot of iron in there. You can have agates. So all of this is just replacement. So it's replacing something that was originally there.